left off? Anybody try?
Little.
A little bit, okay.
Not much.
Not much.
When's that homework officially due?
It's officially due Friday, beginning of class. This is 45 degrees. And these are, all three of these are little ropes. And what we have, this one was C, wasn't it? I believe. And we already did FC. It was 9,800 didn't, do I remember?
No, 8.
Yeah, that'd be better, wouldn't it? Okay, so before we jump back to this, let me back up a step. Let me talk a little bit more about vectors. Whenever you've got a vector, you can always break it into two components, an x component and a y component. I gave you the example we talked about last Monday about giving the directions going to south and north. Basically, I gave you a problem. You wanted to go from here to here, from central Oklahoma City to southeast Oklahoma City, and we went east and then south. So anytime you've got an arrow like this, you can always break it into an x component and a y component. And you can draw it either in that one first, or you can draw it this way first. Likewise, if you've got, you can add vectors. If I've got this vector here, and I want to add another vector. I want to add this vector. So I've got these two vectors, and I want to add them. The way you do this is you put them head to tail. So they both got a direction and a magnitude. The direction is just which way they're pointing. The magnitude is represented by how long they are. Like an example, if you're talking about a map, it's how long the arrow is. That determines how far you have to go. And the direction would be, north, south, east, west, which way you're walking, which compass direction. So if we want to add these two, I'm going to take this one. So I'm going to take that first one. It's straight to the right. So we're going to call this one A, and this one B. So here's my A. And we've got B. Okay, I've added them together. The resultant vector, you start from the very beginning and you go to the very end. It's just like saying, okay, what you need to do is you need to go head east for, say, 5 miles, and then go southeast for 3 miles. You're going to go east for 5 miles, southeast for 3 miles, and you end up here. Or, if it's open fields, you could just go straight this distance here. So this is our resultant vector. So any vector, you can always add multiple vectors up, and any single vector, you can always break it up into an x component and a y component. And these vectors, it's somebody help me. Is it commutative or associative? A plus B is equal to B plus A? Is that commutative or associative? I can't remember. Anyway, A plus B is equal to B plus A. It doesn't matter which order you add them. We could have just as easily down here, I started with A and then added B. I can just as easily go, I can write B first, and then do A. I get the same spot. It doesn't matter